Good afternoon. What is your name?
Albert?
Albert and Eric. Good to see you. So although we don't really have many students actually show up on this Midpoint workshop, but still I'd like to really appreciate you actually put your time and effort coming to campus and meet our faculty members. Okay, so we're gonna begin the Midpoint workshop, and I'm the program coordinator. Okay, so I think you already know about this program, so I don't really need to explain it for you. So the main thing we're gonna do today basically to introduce our faculty already, and also you have a chance to meet faculty in person, and faculty instructor basically will introduce the classes they're gonna teach, and we can then also have some kind of question and answer session. Then at the end, then we'll ask you to finish the survey. Okay, Dr. Cong.
Okay. So I have the PPT or whatever. I'll spend maybe 20 minutes to explain a little bit about 547. This is going to be one of the courses you guys are going to take this fall. It's about software measurement. Okay. So some of the basic information about the class is first the textbook. The textbook I'll use is measuring the software process. Okay, so this is actually one of the very few books give this focus on measurement in software, particularly apply some statistical techniques in analyzing software situations, software context. By the way, this is also the book used by SEI and also by now CMI Institute when they train measurement work. They use this book. So you need to get this book. I list a few references. So for example, one of the first one is practical software testing. I think this is a textbook for 542. Sometimes some of our courses are kind of related. Chapter 11 to chapter 16 will be very helpful. How do you measure software quality? How do you conduct defect analysis? Right, so you're gonna learn that in verification validation class. So if you already got the book, and some of those chapters I think will help you. The next two books, this is the first time I list as a reference. Okay, one is called Measure What Matters. Okay. And this one actually talk about OKR, objective and a key result. This is a technique they use in Google, started in Intel. It's very popular in Silicon Valley. Okay? And the second one is how to measure anything. It's also one of the most popular book published on the subject recently. And elementary statistics is one of the probably the best book on statistics, and I think Dr. Ru actually recommended that book to me. Okay, so they have a lot of real life example. They made the statistic stuff really enjoyable. Okay, so relatively speaking, it's an easy reading. We're going to talk. You can also use some of this CMI book, because this is right now this book is based on CMI version 1.3. Now they go for 2.0, and I'm probably going to share some of the material on the most recent model, 2.0. I list a few other books, obviously not mandatory. If you're interested in the subject, you can learn a little bit more, so those two books will also be very helpful. And throughout, I'll post some additional references. The goal is let's try to get what's most current. Okay, so after all those 20, 30, 40 years, I think the community, software community, we have a better understanding how we can better utilize the data, how we can learn from the past experience. So in terms of the classwork, I do a few things. One, I like to use discussion board. So what I'll do is throughout the semester, I'm going to post 8 questions. Those 8 questions, I'm going to do my best. Try to integrate what's most recent in industry. So help you to apply what you learned. and also maybe help you to get some additional information on most recent topic in the field. Okay. So generally, why look at the discussion board? Why do grading? You know, my grading more on effort. Okay, so because sometimes there's no black and white answer. So sometimes obviously the answer depends on the context, depends on the situation. So you hopefully can apply some of the principle on some of the specific situation. But so effort is more important than correct or not. And also I'll give a final exam. And there will be 2 group assignment, okay? And there will be 1 term project. So one thing for MSE, I guess we have been practicing this, or this approach, learning by doing, okay? And so those assignment and also term projects, and we kind of encourage you to work as a group. So in terms of the group, number of group members, usually we do like a 3 to 4 to 5. If you guys already have a group in your previous class, you want to keep the same group, that'll be fine. Okay, so if you want to form a new group, you can certainly do so. And generally speaking, I'll give you enough time. Try to give you the assignment or posting the discussion question early enough. You will have more than enough time to finish. Okay, so generally speaking, I don't accept any late work. Okay, so I guess you probably realize now to do well in this setting, virtual or online, we're doing online, planning and a discipline, probably two most critical factors. So look at, for next semester we have two courses, right? Many of you probably have to work, okay? Family, kids, you have to balance a lot of things. Okay, so look at the syllabus, look at the milestone, look at what are due, when, then you probably should plan your time. Okay, so this is asynchronized, so you have a lot of flexibility. Okay, so we're proud like to be in the mode of anytime, anywhere. Okay, and most of the due date I gave is Monday, so that means you probably can use weekend. Okay, but you can definitely finish early. Okay, so some of you, if you rely on, you have a lot of things to do during the weekday, and then you can spend some time on the classwork on weekend. Okay, so for grading, typical 90, for sure you got A, 80, 89, B, 70, C, over 60, D. Okay, so less than that, F. Okay, so I guess pretty much same as before. Now let's look at the content. What will be taught? Objective of the class. So one, hopefully you can learn what's current and also practical approach in measuring software engineering. Okay. Usually other engineering discipline, we don't have a class called measuring, like a double E, or mechanical engineering. Obviously measuring is important, but you don't make it a class. But software is actually kind of unique in terms of measuring. For example, how do you measure the work? So you're building a software. Okay, what's the amount of work I'm going to do? So it's a so-called measuring size. So even today, we still don't know how to measure the size. If you use a line of code, that's not the correct measure for the work to be performed, right? So now some of you probably heard the functional point. But again, functional point, they basically provide a very abstract model. And it's very difficult to apply every unique situation. Okay? And how do we measure software quality? Just use defect? Zero defect means a good, high quality product. So what about value? Do people like your product? Do they buy your product? Okay? How do we get the feedback? How do we know what's working, what's not working? So this has been, I guess, a very good area. A lot of people devote a lot of time. So hopefully we can present what's current and also what's practical. Okay. Another goal is a little bit more specific. How do we measure software product? How do we measure software project? And also how do we measure software process? And one thing I think is kind of unique we do in this class is we learn how to analyze process behavior using statistical technique. So a lot of you probably know Deming. Okay? And the technique he developed, so-called SPC, statistical process control. Okay? How do you statistically understand the past? How do you statistically control present? How do you statistically predict the future? Okay, so this is basically the key. And also one of the highlights of the textbook, so they actually talk about this, how do we build control chart. So it's a very simple and elegant mathematical approach to analyze process behavior. Okay, so maybe I'll also along the line teach a few practice on CMMI high maturity stuff. Okay, and some of the best practice and also lessons learned in the industry. So those are the objectives. So this is the plan, the tentative schedule. So what we're going to do, and also the pace. So based on the textbook, first 2 weeks we're going to cover some of the basic concept of the measurement, which is basically chapter 1. Class project, I'm going to actually post some sample. You're going to see some example. I gave some idea what could be a class project. Okay, I'll post that this week or next week. Okay, and we're going to cover a little bit about the measurement given defined in CMMI, so which is a common industry, even though most of the user in DoD, but still is one of the most widely adopted software development model. And we cover planning for measurement, use a couple of weeks, and also how do we collect data, okay? And also we're gonna use some time to discuss some of the basic statistics we probably need to know, okay? Some of the high maturity practice given in CMMI 2.0. And one of the focus of the class is we're going to spend some time and use a lot of example to learn how we can analyze process behavior and understand the concept of variation. So for example, the idea is like you do test, so you do a system test, same environment, okay, and same process. For example, the coverage, the test case coverage, the requirement is the same. Same team, you have an independent QA team, right? So everything is the same. How come every time when you do a test, the performance is different? The defect density identified is different. Sometimes it's high, sometimes it's low. What's the cause of that? Can you identify some issues? How do you know the defect identified is high? How do you know it's low? Okay, so those are actually some of, how do you know when you can stop testing? How do you know you are confident, particularly doing mission critical software, and the product you release will not contain any major defect? Okay, so those are some of the things you probably can apply with this so-called process behavior. Okay? Then we're going to have a homework 2 after we finish chapter 4, and then we're going to actually get into more detail on control chart. Okay, so this is actually the textbook. You get to chapter 4, chapter 5, and chapter 6. Okay, so they actually spend a lot of time discuss how we use control chart in process behavior analysis. Okay. And then we're going to talk a little bit about so-called stable process to capable process. This is obviously the key for process improvement. Stable process, what that means? That means I can predict. Okay, I know if I go through this, what the result will be. I can tell you what's the central line, the average. I have a confidence degree. I can tell you the range, max and the mean. Okay, so which is stable. Can be, you basically pretty much can predict. But stable may not be capable. Capable means meeting customers' expectation, meeting their requirement. I can deliver, the lead time, I can deliver within a month certain feature. Okay, but I can predict, I can deliver in 3 months. That's stable, but that's not capable. So why I need to do improvement? So I want to make my process from stable to capable. So probably I should do more automation. Maybe I should enhance reuse. Maybe I should improve my architecture design. Okay. Maybe I can reduce customized development. So you have to do a few things, okay, to achieve. But how do you know where I should improve? This is where the data can help you. After you're done, how do you know you achieve the result? How do you know now you should deploy this to a bigger scope? Okay, so anyone, if you're gonna one day become a manager, okay, so you have to learn how to use data to do a better decision making. Okay, so we also can talk, some of this more practical approach to do improvement. Okay, and so this is actually very closely related to some of the courses you learned before. For example, requirement class 541. Right, so obviously, we had a discussion, I guess in the morning, talking about the requirement. Doing the right thing, comparing to do things right, doing the right thing is more important. Doing the thing right is what? I build the right testing process. I build right estimation process. I build right management process. Right? I build the right design process. Doing things right. But if you're doing the wrong thing, what's the point? Doing the right thing is more important. Doing the right thing means what? You need to understand the requirement. But sometimes, do you know the customer, or you know what's the right requirement? You don't. So developing software is a learning process. It's very difficult to, in the very beginning, when you know the least about the user, about requirement, about technology, then you try to decide everything. Because for sure later on, you're going to have to change. So you're going to increase your rework. Okay, so in this learning process, the measurement become very important. So now, I guess a lot of you probably know the Agile. And so this probably become the mainstream development. But how measurement affected? DevOps. Okay, so now everybody building the pipeline, the tool chain. So in this process, in this new setting, how measurement will be affected. So obviously the way we do it will be different. And we're going to try to learn all that stuff. And obviously if we just rely on textbook itself, and the textbook was published 20 years ago, at that time there's no DevOps. Right? And there is no, the Scrum is available, but very few people knew it. Okay? And a lot of things is different. Okay? But a lot of the basic idea, the principle still applies. So we need supplement, okay, and the textbook with some additional reading and also with some additional discussion. Okay? So here are some of the idea for potential project topic. It's a very flexible, best practice, case study. I love case study. Okay, so I know a lot of you are working right now. Trust me, analyze how some of the decision made in your project, see how data is utilized. Okay, if all your decision made is just based on experience, based on feeling, I don't know, so it may not be the most scientific ways. So you're probably going to make the wrong decision a lot of time. Because those has a lot of bias. You want me to make a decision, I'm going to base on my experience. I'm going to base on what I like. I'm going to base on what I think is important. But if you use data, particularly those data objectively collected, then you conduct analysis. And you're going to increase your chance to make a better decision. So some best practice will be great. And one of the most mature field, some of you be interested in quality control, quality management. How about software quality metrics? Okay, for example, so this is the old approach. The goal is what? When we deliver the product, software product to the user, you want it to be what? Zero defect, right? So how do I want to reduce number of defect escape to the user? Basically, you have to do two things. One, you either what? Inject fewer defect. When do you inject your defect? when you do requirement analysis, when you do design, and probably majority of the defect injected during coding. Okay, so one of the process improvement is, let's try to do that better, inject less. What's another approach? You can learn in verification and validation. So how about let's try to discover, identify all the defects before we release the product. How do you identify the defect? Through peer review, technical review, right? After you finish your requirement, you have all the important folks sit together, let's look at it, see if there are any potential issue. After the major design, you do the review again. And then obviously most of the later quality control work are testing. You do unit test, right? You do integration test, you do system test, you might do some user acceptance test, you may do a pilot run. What are you doing? You try to identify all the defects before you let user use your product. But how do you know for sure there are no major defects left? Okay? And so one of the application for software measurement is, this is actually one area we can answer. We do have a good solution. So interested in that, you might do a project in that area. How do you measure software size and effort? Okay, COCOMA, functional point, line of code. There's so many different ways. In your organization, how do you know your project is worth $20 million? What's the basis? Okay, so sometimes we don't know. Okay, so sometimes, it's an educated guess. So this has been something, okay, and that make our whole software engineering foundation kind of weak. So if you're interested in that, you can, maybe again, find some practical solution approach and also maybe application. And if some of this is, I can say I'm a semi-expert. Okay? I'm a certified instructor, lead, and so on. So if you're interested in terms of metric, how you go from level 2, level 3, level 4, level 5. What's the involvement? And I don't know any of you from DOD. If from RISIA, you probably know you're a level 5 organization. Okay. Some of you, if you're doing like a vendor, the DOD vendor, maybe a level 3. So in 2000, if you're not level 3, you can't even bid a DOD contract. Okay, so how data is involved? So that could be something. Six Sigma, anybody familiar with Six Sigma? Okay, so statistics, right? Quality control, DMAC. So what happened to the data? Yeah, data is what? Throughout the whole process. Okay, so if you want to apply that in improvement and in decision making and a lot of things, so that could be a good area to study. And SPC, statistical process control. Okay, so that would be, I know Six Sigma, do you have a belt?
Green belt.
Green belt, okay. So you got all the training. Okay. But by the way, if you have become a black belt, after everything, test, training, you have to lead an improvement initiative. The return of the initiative must be $1 million. If you do that, you got a black belt. Okay, so you basically have to apply what you learn in practice. So, we try to do the same thing. Anything in some of the new area, Agile, okay, well, it's not new anymore. Kanban. I call the next generation of Lean, DevOps, DevSecOps, okay, and the CI/CD. And now when they build CI/CD, they actually start early, they end it late. Right? So they kind of extend the whole process. So not only they can reduce the lead time, they also can maintain quality. How do you know? If any of you done a CI/CD, do they have a quality gate? Real time, right? So after I check, am I meeting the requirement? You identify defect right away, but also you're gonna have to make a decision. Should I continue? Should I fix everything and then we continue? Data will play a key role over there. So CI/CD actually greatly influence how we measure software. and a few other things. And a few other, like a topic could be model. Okay, this is also in semi-high maturity, the so-called process performance model. For example, reliability growth model. Okay, some of your organization may use it, I like it. So basically, they can tell you if you have any defect left or not. Okay, so we may have a COCOMA. How do you measure size? Very lean. So this is DoD actually use that to decide the value of a software product. Is that a $5 million project? Is that a $50 million project? So, and also in your own organization, how much really, if you're a manager, if you're a resource manager, how do you decide I need 10 people for this project? I need 12. What's the basis? Is that whose voice is the loudest? Okay, so a smart, mature organization, they use data. They use historical data. So usually this will provide better value and a better ROI. Complexity model. We all say one of the key to be successful in Agile is what? You know what's the most difficult thing to make your Agile work? How do you break your requirement from big to small? How you reduce the bench size, right? You have like a 2-week sprint. You want to continue to release. When you release, don't you want to release some independent, right, feature that has value? If I want to drive a car, you just give me a wheel, I'm not going to be able to do anything. There's nothing to release. You just give me a wheel. Right? But if you give me a scooter, hey, I can use it. I can provide feedback. How do you break big feature into smaller one? That's the key for your Agile to work. So at the end, I have something I can deliver. And also at the end, I got something I can get feedback. Sometimes you develop a feature, no one can give you feedback because I can't use to solve anything. There are a lot of research that's been devoted to this area. And in measurement, we call something called complexity model. So there's some research work and also a lot of companies based on their own context, they build their own. So if you're interested in that, that could be something you can use any other model. Okay? And this list is very small percentage. Okay, so you can pick your own. The key is we need to reach some agreement. Okay, so each team need to write a little proposal. Just tell me why, what, and how, and when, and by whom. Hey, your team, right? And I look at it, I'll give you some suggestion, and if we agree, that will be your basis for the term project. Okay, so I want you to do something that a term project can use what you learn, and hopefully that can benefit you. You might be able to use in your work. I think I teach a project class. If you recall, one thing I already encourage you is, can you get something out of your work? Okay, because then you have one stone, you can kill 2 birds, and also you have more incentive, and also you have more value. Okay, and so as long as the project topic, get my approval, it will be fine. And so here are some of the important dates, tentative dates. Okay, so obviously I'm going to post everything online by tomorrow. So you should be able to get everything anyway. And I'll try to post all the lecture early. And so just try to help your flexibility. Okay? And so those are the dates. The final, I think usually people worry about the final. I have always been doing this. You don't have to memorize anything for this class because I got a bad memory. I can do it, I won't ask you to do it. And try to understand. Can you apply? I give you a situation. I'm never looking for a perfect solution. In software engineering, there's no perfect solution. In measurement, there's no perfect measurement. If anybody tells you this is perfect, no improvement needed, things are going to change. I never believe in best practice, even I use the term, because people use it. The best practice depends on time. Best practice 10 years ago, today, no. It's a bad practice. Best practice for IBM? You go to Google? No, that's not a good practice anymore. So best practice depends on the time depends on the context, but some general principle, general thinking, general technique, well, you should learn. And then you need to be creative. Anybody heard the term digital transformation? It's a huge buzzword, digital transformation. I think very few people truly understand digital transformation. Digital transformation basically says IT is more important than anyone. Before IT is, business, you have something, I'll do it. I'll try to deliver quickly, or try to deliver without defect. Now it's different. Now, what's the digital transformation? One thing is, okay, I have this new technology. Can we do something, generate some value for the whole organization, particularly for the customer? After you deliver a product, how do you know your product is good? Old time, talk about measurement. What's the revenue? What's do we deliver on time? Do we do this? Do we do not? Do we do that? It's basically you measure your own business success. If you do digital transformation, you should look at it from a user point of view. After you release your product, what did your user gain? Does this bring some value for your customer? You see, the view is different. So the measurement will help you to focus on the important thing. Okay, and so now, one of the measurement I'm really, usually I think is the most important is called lead time. A lot of lead time is basically the way we got this idea. Then user can use it. Can we reduce that time? So requirement, there is a fuzzy front. Understand requirement. Can we reduce that? Then we have development. Then we have transition, DevOps. So we try to basically speed up the last part, right? And how about the first few part? Okay, so in this process, measurement play a key. So measurement basically is a light. Let you see, make your process transparent. Okay, so let you see where are the issues, where are your pain point. Okay, so there's no perfect solution. Okay, no perfect measurement. We focus on something practical. Okay, so you can do something. So you don't need to memorize anything. Okay, because they're not going to help you. Okay, and I give you it's like here is a situation. How are you going to do it? So usually, there's no one single uniform right answer. Okay, perfection is the enemy of good. Okay, so in our field, get something work. Then what? Refactoring. Continue to improve. Learn. In this process, use data. Okay, so that's what we are going to try to do in this. Okay, I guess that's it. Any question?
I think you already answered. I was going to ask how close the description was to like a Lean Six Sigma course statistics, and it seems very similar to a lot of like the statistical process control and analysis and confidence intervals and stuff that we would do.
Yes, we can still apply, except in a different setting.
Yeah.
And the way some of this the mathematics are beautiful.
Yeah.
Okay, so they have value. Maybe in another 1,000 years, it's still very valuable. Except we use them, apply different contexts, different solution. Okay, so the key is, increase your knowledge. Can I use it? It's not like can I memorize it. So if you're like me, after 5 years, I don't know, after 5 months, forget everything. But if it's become, like do Agile, doing Agile is bad. Not a whole lot of people understand Agile. Being Agile is good. So this has become part of your thinking. So, it's the mind side. Right? A lot of people did not realize, because things are going to change. Anytime you say Scrum, I must have this process. I must measure this. It's not Agile anymore. You talk about SAFe. One thing, I have some issue with SAFe. Okay, so you look at it, it's very prescriptive. So you define this. Gee, anytime you give me a lot of constraint, I don't think it's Agile anymore. Agile, basically, the key is learning feedback, improving value. You should not have any whole constraint, right? I cannot use this, I cannot use that. You see, you know, here's a story I heard. You know, there's a workshop. Oh, we're gonna start Agile. Agile, one thing about Agile is what? We have self-managing team. You guys are gonna make a decision, first line. Oh, okay, by the way, the Scrum training start tomorrow, everybody to show up. Okay. Okay, sprint must be 2 weeks. So every 2 weeks you're gonna do this. Okay, every day we're gonna have a 15-minute stand-up meeting. In stand-up meeting we're gonna do this. Gee, I thought you let us decide. See? Think about it. So not a whole lot of people understand, is this the only way to do it? If that's the only way to do it, is that Agile? Okay, so, you know, so again, do I have to measure? Again, you ask me, anytime they ask you, say, this must be done as the method, as the metric, I don't think, that, you know, probably is wrong. And also another thing is, you know, your measurement, proxy measurement, you know, sometimes hurts you. Give me an example. Everybody talk about productivity, right? Productivity, right? 1 month I can produce 1,000 lines of code. Okay, now I can produce 1,200 lines of code. Is that good? I don't know. Can your user see the difference? If the delivery time is still the same, you still have all the bug, you think they care? Because the lead time in this process, not just coding. What else do we have? We have waiting time. We have rally. You have like, we done with requirement, then what? I'm going to pass next group. Then I'll pass next group. Then I'll pass next. Every time when you're passing something from one group to the next group, usually you have trouble. How do we know everything's under control? Again, you can, you know, mature organization, they have some metric. So metrics, there are some scientific, fundamental approach, and use Six Sigma, right? By the way, you cannot apply face-to-face 100% Six Sigma in software. Because in software, no two software projects go through exactly the same process. But the way they build what? They produce this identical. Okay? So software, no. So how can you apply exactly the same idea in manufacture? Right? In manufacturing product line into software product line. Okay, so it's very different. So that's why, you know, hopefully you can learn some of the essence of software engineering. Any other question?
Okay, that's sounds like a great seminar. I think the idea is not just introducing his class, but he gave a lecture to talk with his insight. Okay, really appreciate it.